Today we discuss about the light chapter, O level physics chapter light. So this light chapter we have to divide into three parts. So the first part is that related to reflection of light. Second part is related to a refraction of light. And the third part is related to the lenses. So today we have to discuss the first part, a reflection of light. So first, light, form of energy. Second, ray of light. Representation. Light, how we represent simple straight line with arrowhead. Beam of light. This is the beam of light. Bundles of rays of light. Now the reflection of light. Bounce back of a light from surface. Terms related to the reflection. Reflection of light. This is over reflecting surface. This is over incident ray. This is over reflected ray. Incident ray, reflected ray. This is over normal. This is over angle of incidence. This is over angle of reflection. Incident ray, ray travel towards the reflecting surface. Reflected ray bounce back from the reflecting surface. Angle of incidence it is the angle between incident ray and reflected ray. Angle of reflection it is the angle between reflected ray and normal straight line perpendicular to the surface or point. Point of incidence point on the reflecting surface where incident and a reflected ray meet. So the point of incidence on the diagram, this is my point of incidence. This is the point of incidence. Laws of reflection. Incident ray, reflected ray and normal all lie in the same plane. Plane means flat surface. Angle of incidence always equal to angle of reflection. So these are the 2 points valid allwhere in the universe. So laws that remains constant everywhere in the universe. So these are the 2 laws. Now the next part is that image application of reflection. So first of all, image Picture of an object. Picture of an object. Or geometrical shape of an object or geometrical shape of an object. Types of image. Real, virtual. Real image, image that caught on screen, and light rays and actual light rays meet on screen to form image. Screen is your any surface and on which light is reflected. So example, image formed by projector, photo, and larger image formed in eye and camera. Virtual image, image that cannot be caught on screen, and light rays appears to come from an image. Only our brain perceive that is image is formed. In reality it is not formed. That is the virtual image. So that is the important point, that light ray appears to come from an image. Example, image formed by magnifying glass. Image formed by plane mirror. Plane mirror. Now we have the application of reflection, and that application is plane mirror. Plane mirror, flat mirror, and then we have the plane mirror application. We have mirror periscope, and then we have blind corners. So plane mirror, image characteristic of image formed by plane mirror. Characteristics of image formed by plane mirror. Number 1, it is virtual, it is erect or upright, laterally inverted, right side of object appear as left side of an image, left side of image. Image size is same as object size. So these are the characteristics. Now the position of image behind the mirror. Position of image. Formed by plane mirror. Image formed behind the mirror opposite of object. Image distance and object distance from mirror is same. Line joining object and image is perpendicular to the surface of mirror. That is the important point. Now to locate, with the help of diagram, we have to discuss about the points. We have to discuss about how to locate position of image behind the mirror, how to geometry of locating image behind the mirror. So side by side we have to discuss the point, and also again we draw the diagram. The first point, suppose we have this is my mirror and this is my mirror, and this is my object. Now the first step is that image formed behind mirror opposite to object. So the image is formed here. This is the image is formed here. This is my image. And at what position? Image distance equal to object distance from mirror. So this is my object distance d1 from the mirror, and this is my image distance d2 from the mirror. So this is d1 equal to d2. So image distance from the mirror is equal to object distance from the mirror. And the third step is very important. Line joining object and image is perpendicular to the surface of mirror. So this line is make a 90 degree. If we join the image and object with a straight line, it always perpendicular to that line is perpendicular to the surface of the mirror. So in the MCQs, if you draw the line and if you see if the object is from object to image, the line is not perpendicular to the surface of the mirror, so that is the wrong diagram. So that is the incorrect option. So please, the first of all, object image is always formed opposite side of the object behind the mirror at equal distance. Object distance from the mirror is equal to image distance from the mirror. The fourth step, draw two reflected rays from mirror which passes from image which passes through mirror. So I draw two reflected rays so these I draw two reflected rays behind the mirror. At any angle you have to be draw it, multiple lines you have to be draw it. So these two rays, this is over I, so minimum you have to draw two rays, and this is over incident ray, this is over incident ray, this is over reflected ray, and this is the reflected rays, and this is over incident ray. So the last point is that draw two incident rays from the object which meets the reflected rays at mirror. So in this way we locate the position of image. So this is the virtual. In actual, light rays appears to come from the image, so we are not able to follow the direction of the reflected ray. We always see in the straight line, so that is why we see in the straight line. So light rays appears to come from this point, so that is why it is virtual image. So light rays appears to come from this point. Okay, now the next part is that note that image formed by plane mirror image formed by plane mirror is laterally inverted. What this means, laterally inverted? Right side of object appear as left side of image. So if you raise your right hand, so the image hand is left side of the image hand. So in examination they ask about E, letter E. So laterally inverted image in plane mirror, image in plane mirror. P, so we have to be CP. B, we have B in this way. So this is the laterally inverted, that right side of the object appear as left side. Okay, now the next part is that maximum height height of mirror required to see full of object. So suppose if we have the mirror, so this is the mirror. So if we have the height of the object, we have A, B. So how much is required? That is the formula we have to require. Maximum height of mirror required to see full image of object is equal to half the height of object. If object height is 100 centimeter, so we required 50 centimeter height meter to see full image of object. Now the next is linear magnification. Linear magnification. So the linear magnification significance it tells about magnification of image represented with M. So definition what is the definition? Linear magnification image height divided by object height or image distance object distance. If m greater than 1, if m equal to 1, image size and object size are equal. If m greater than 1, image is magnified. If m less than 1, image is diminished, smaller than object. So note linear magnification of image formed by plane mirror is 1 because image size and object size are same. Now we have application of plane mirror. Number 1, mirror periscope. Number 2, blind corners. Mirror periscope Periscope is the optical instrument which is used in submarines to see the. So we have Z-shaped tube submarines. This instrument is used to see the elevated object. In submarine it is used to see the object on the surface of water. So mirror. So we have the object A and B. So these mirrors are inclined at 45 degree. 45 degree. 45 degree. This is also 45 degree. 45 degree. So the next. So the image is same, the same characteristic is the image as the plane mirror. So it is the image is laterally relaterally inverted. Rest of characteristic is the same. Rest characteristic stick is same as plane mirror. So 2 times it is reflected from the mirror, so that is image is relaterally inverted. Okay, blind corner video, I will attach the video in the notes. The blind corner, you will see that how the image is formed in the blind corners. So the next is the blind corner next application is blind corner. Okay, the video is attached in this note of this blind corner because it requires the ruler for the proper drawing. So blind corners, what we have to do is that so we have two cars, A and B. The car A, this is the car A. This is my mirror at the corner. This is the car B. Now the car A see the image of car B. So how it sees, again we have to locate the position of image behind the mirror. Okay, the first step that image is formed, the image of car B is formed behind the mirror. Image distance and object distance from the mirror are equal, and the line joining object and image is perpendicular to the surface of the mirror. Now we have to be in order to execute the third point, we need to extend the mirror. So we need to extend the mirror. So the mirror, we extend the mirror. Here we extend the mirror. So I extend the mirror. So this is for the geometry purpose. So now we have to draw a line which is perpendicular to the surface of the mirror. So now this is the line. So this is the image of car B, because now this line is the object and image is formed behind the mirror. Object distance from the mirror and image distance from the mirror are equal, and the line joining object and the image is perpendicular to the surface of the mirror. This is the 90 degree. Now we draw two reflected rays. Now we draw the reflected rays which can be seen from the image. Reflected rays coming from the image seen by the driver A. So from this image I draw this reflected ray. This is my reflected ray seen by the reflected ray. This is my reflected ray, and now we draw the incident ray. Incident ray we have to be draw the incident ray. So this is my incident ray. This is the incident ray which meet the reflected ray at mirror, and this is the normal. So this is our incident ray. So that point is very important, that we need to extend the mirror line in order to locate the image behind the mirror, because the line joining object and image is perpendicular to the surface of the mirror. That is why we have to draw this extended mirror line. Now for the image of car A, repeat this diagram. For the image of car A, repeat the steps. Is that so this is my car A, this is my car B, car A, car B, this is the mirror. So now the image, to locate the image, need to extend the mirror. So this is in order to extend the mirror, and now the image is here, because image of car A with the ruler, object distance from the mirror and image distance from the mirror are equal. This is the perpendicular line joining object and image, and this line is, so that is why this is the extended line. We draw the extended line, so the image and the object is line joining the perpendicular to the surface of the mirror. Okay, now draw the reflected rays from the mirror. This is my reflected ray from image. So light rays appears to come from the image. This is my reflected ray, and this is my incident ray. Incident ray. Incident ray. So I draw the normal. This is my normal. So in this way, the driver B sees the image of car A. So both diagrams, that is the blind corners, both the car image of car B and image of car A. From ATP point of view, we have to just write the experiments they ask in the examination from this reflection topic. ATP topic. Number 1, verify laws of reflection by ray or pin method. Foley experiment is asked, and sometimes asked just question related to the practical point. Verify laws of reflection by pin method. Locate the position of image locate the position of image formed by plane mirror using pin method. So these are the topic of the ATP. Thank you.